So for part A here, we need to rationalise the denominator of 22 over the square root of 11. So to do this, we need to know the fact that, okay, the square root of something, let's say A, multiplied by the square root of the same thing, just equals that thing. Now essentially, rationalising the denominator means getting rid of any square roots on the denominator here. So we can use this fact to our advantage. So we're going to grab our fraction, so 22 over the square root of 11. Okay, so using this fact over here, to rationalise the denominator here, what we're going to have to do is multiply by the square root of 11. For whatever we multiply the denominator by, to keep it the same fraction, we need to multiply the numerator by it as well. On the bottom, it's going to give us the square root of 11 multiplied by the square root of 11. And on the top, 22 multiplied by the square root of 11. And we know that on the bottom, that means we just have 11. Now we're almost there, but a key part is it says that we need to give our answer in the simplest form. So we can now divide the top by 11 and divide the bottom by 11, which gives us 2 square root of 11 over 1. And because there's no more common factors to divide by in the numerator and the denominator, we've reached the simplest form. So our answer is 2 square root 11. So we get 1 mark here for our working and our final mark for the correct answer. So in part B, we need to show that the square root of 3 over 2 root 3 minus 1 can be written in the form a plus the square root of 3 over b, where a and b are both integers. Because essentially, even though it's not saying it, what we need to do is rationalise the denominator. What we want to do when we want to rationalise something that has 2 terms in it is we multiply by the same thing, but we flip the sign in the middle. So in this case, we're going to have 2 square root of 3 plus 1. So because we've got a minus here, we're going to make it a plus. If in another question it was plus here, we'd make it minus here. Remember, when we multiply something to the bottom, we need to do it to the top. And now we need to work out what this is. So on the top, we're going to have the square root of 3 multiplied by 2 root 3 plus 1. And then we're going to write it in 2 brackets to make it easier to see. So we've got 2 root 3 minus 1 and 2 root 3 plus 1. So we need to expand our brackets on the top and on the bottom. So multiplying out on the numerator, we're going to have square root of 3 multiplied by 2 square root of 3. So that's 2 multiplied by square root of 3 multiplied by square root of 3. However, we learned from the previous question that in this case, that will just equal 3. And now we've got 2 times 3, which we know equals 6. Then our second term, we've got square root of 3 multiplied by 1. So that's just going to be plus square root of 3. So now on the bottom, we've got a pair of brackets. So we treat this just like we would have, you might have seen it, and when we're using a quadratic, so we might have an x term here and an x term here, and it's been factorised, and we want to expand it. So we can do this in the exact same way. So look at the first terms here. We're going to have 2 root 3 multiplied by 2 root 3. So if we look at this, the root 3 multiplied by the root 3, that's going to equal 3. So what we're going to have here is 2 times 2 times 3. So if we work this out, we've got 2 times 2 is 4, times by 3 is 12. So all of this is 12. So I'm going to look at the outside terms. We're going to have 2 root 3 times by 1, just giving us positive 2 root 3. And the inside terms now, we've got 2 root 3 multiplied by minus 1, giving us minus 2 root 3. And the final terms, we've got minus 1 multiplied by 1, giving us minus 1. And you'll see this is why what we did works. Because we flipped the sign here, we see we've now got positive 2 root 3 and negative 2 root 3. So they cancel with each other, getting rid of all of the square roots. Meaning on the bottom, we've just got 12 minus 1, which is 11. And on the top, we've still got our 6 plus the square root of 3. If we have a look up here, we know that we've probably done it right because it matches up perfectly. We've got our root 3 here and our root 3 here. And we know that our value for a, which is an integer, is 6, and our value for b is 11. So we get our first mark here for realising what we need to multiply both the denominator and the numerator by. We got our second mark for carrying it out to this stage, and the final mark for the correct answer in this form like this. Or alternatively, for the final mark, you could just write that a is 6 and b is 11.